Alright, this is a new topic, homogeneous functions. If z is equal to f of x comma y, or if z a function of x comma y is a homogeneous function, then it could be expressed as z is equal to x to the power n, a function of I guess that's a function of y over x. In general, a function x, y, z, and c. So, like you're given an equation with a function of x, y, z, and c, a function f, x, y, z, and c. I'm sure you get this pattern by now. It's said to be a homogeneous function of x, y, z, and c of order n if it can be expressed in the form x is to the power n, a function of y over x, z over x, t over x. So we're talking about homogeneous functions. Just say that for a function to be homogeneous, it should be expressed in this form. It should be expressed in the form x to the power n, a function of y over x. That's if you're just giving x and y. But for where you're giving more than x and y, here you're giving x, y, z, and c. It means that basically you're factorizing the x from the equation. I'm sure you can already see a glimpse of the example there. You're factorizing the x from the equation. Wait, it's not time to see the example. You're factorizing a glimpse of the you're factorizing the x from the equation. So when you bring out x raised to the power n, a function of y over x, z over x, t over x. So let's do an example so that we'll understand it better. Now the example is you're asked, is u equal to 3x squared y squared minus 2x y raised to the power 3 plus x raised to the power 3y minus x to the power 4 a homogeneous function. Solution: u is equal to this. What I normally do, I normally factorize the highest power of x first. The highest power of x is 4. Factorize it. If that one does not work, maybe take one step higher or a step lower. But most times, the highest power of x, in most cases, like in this case, let's factorize out the highest power of x. So let's bring out x over 4. Recall, we want it to be in this form. X is power n. So x is power n. Here is x is power 4 brackets. This is what we are talking about now. Y over x, z over, but this is just x and y, so it's just y over x. So in this form, so let's see, x is over 4. When you bring out x over 4, you know how factorization works. This is going to become y over x raised to power 2, such that when you open it, this is going to become y squared over x squared. When you multiply it by x raised to power 4, this will cancel, this is 2, you'll be left with x squared y squared. So this times this will give you this. That's what we mean. Minus 2 y over x raised to power 3. You also get y raised to power 3 over x to the power 3 times x raised to power 4. Cancel, you get x y raised to power 3, x y raised to power 3. So this times this satisfies this, plus y over x, multiply it, so you get this. X over 4 into x over 4 is actually 1. So this function, this clearly satisfies this equation. So this function is homogeneous of degree 4. Degree 4, that's the highest power of the unknown that we are differentiating with. So the degree 4. So the function is homogeneous of degree 4. So if you check this, our n is actually 4. Our n is 4 here. Now you're asked again, is v a function of x, y, and z? Now v now has 3 unknown variables. Oh, the solution is already showing. Okay. So you have 4x y z raised to the power 3 minus 2x squared y raised to the power 3 plus 6 y raised to the power 5. Is it a homogeneous function? Solution, you write down your question. So like I said, this one now, funny enough, is homogeneous of degree 5. You just need to check 1, check 2, check 3, or you check from your highest power of x. If it doesn't move, then you just check 4, check 5. You just keep on checking. You analyze, and you've, okay, like now you've gotten to 5, the highest power of y here. Okay, so I won't say the highest power of x, I will say you start with the highest power of the unknown there. Start with the highest power. The highest power of the unknown here is 5. So that, I guess that's why you just immediately went to x to the power 5, and it satisfies the equation. When you take out x to the power 5, your y is raised to the power 1, so you have y over x, your z is raised to the power 3. When you multiply this, x cancels x, you have 4. X to the power 3 cancels this, you have 1x left, so you have x, y, z. So this multiplies this to give you this. You just have to be careful and look at it to ensure it works. Here you have 3, so you have y over x is power 3. But when you open it, you have y raised to the power 3 over x is power 3. When x cancels this, you'll be left with 5 minus 3, that's 2. Lots of indices, when you're doing division, collect the base minus the power. So you have x is power 2, that's what you'll be left with. Plus this, y is over 5 over x is over 5. So this actually satisfies. So this function is homogeneous of degree 5. The function is homogeneous of degree 5. So now, is this function a homogeneous function? 2x y squared plus xy plus 2x raised to the power 3 plus 5y squared, is it a homogeneous function? Nope, it's not a homogeneous function. If checked, I have checked. If we say x is to the power 3, okay, let's have it 3. If you put it here, this will actually work. For this one, it will work. X squared will cancel this square, and you'll be left with just 1x. But this one, x will actually cancel 1, you still be left with x squared. So this does not work. This one will work. This one also does not work. You actually need another x here. Or 2. Since let's say the highest power of y now is 2, it won't work here, definitely. So this is not a homogeneous function. This is not a homogeneous function. So I tweaked it up a little bit. So just what you do now, you personally, you check if 2x y raised to the power 2 plus x squared y plus 2x raised to the power 3 plus 5y raised to the power 3 is a homogeneous function. I guess it is a homogeneous function. Alright, that's it.